So, first question is Rahul has a 5-page assignment due in 60 minutes. He can write one page in X minutes. Determine if Rahul can complete the assignment within the given time constraint. Means like he have 5-page assignment, he should complete that assignment in 60 minutes. Now we are given with X minutes of time where he can take to complete one page. Now we should find whether he can complete that assignment within the time constraint 60 minutes. 60 minutes. So that's what we need to do. Simply we'll multiply 5 with x. So this is the total time taken by him to complete that assignment. If it exceeds 60 minutes, then he can't complete within the time constraint. So we should print no, else we should print yes. That's it. It is simple question. Next, we'll move on to second question. Yeah. In a football match, a penalty shootout is used to determine the winner if the score is tied after the regulation and extra time. Each team takes turns attempting 5 penalty kicks. Team A has scored X goals in 3 turns, while Team B has scored Y goals in 4 turns. Now determine if it's possible for the penalty shootout to end with equal score after both teams have taken all 5 of their penalty kicks. Now T is the number of test cases. Now we are given X and Y, where X denotes the number of goals scored by Team A in 3 turns and Y represent number of goals scored by Team B in 4 turns. Now we need to find after 5 turns whether the scores will get tied. If the scores will get tied, then we need to print S, else we need to print no. That's it. So let's observe the test cases here. Here there are 3 test cases. First test case is 1 and 1, where x equals to 1 and y equals to 1. Means in 3 turns, here X team A score is 1. In 4 turns, team B score is 1. So already scores are equal. So after 5 turns, if the goals are 0, then the score will remain same. So definitely when X and Y are same, we need to print S. That's for sure. So that's what I wrote here. Now let's see the first test case. X equals to 1 and Y equals to 2. Team B has higher score than Team A. So now to get the scores equal, so here the score, the Team A score should get increased. So we need to increase this. So this score was for 3 turns. Now still we have 2 more turns. We'll check. First we'll increment 1. So after 4 turn, we'll check that score. Will that equals to that y? If it is, then we'll print s. Then if it doesn't, then again we'll increase 1 more and we'll check whether it is equal to y or not. If it is, then we'll print s. That's what I wrote here. X plus 1 equals to y or x plus 2 equals to y, then also we'll print the s. And next case is here x is greater than y. So when for this type of cases, the scores will get tied. So if will this is the number of score after 4 turns. So we have only one chance. So we'll increment by 1. If that value equals to x, then we'll print s. Else we'll print no. That's it. X equals to y plus 1. So here there are 3 cases when x and y both are equal, and when x is greater than y and x is less than y. So simply for these cases we'll print s, else we'll print no. That's it. Is there any queries for these 2 questions? Any doubts regarding these 2 questions? Now the remaining 3 questions will be taken by Sushmita.
Hello, am I audible to one? If yes, so then you can write in the chat box. Okay, so if you have solved the solved question number 3, then you can send your approach in the chat box. We will try to see that. So let me share my screen. This is step 4. We are solving questions for. Okay, so I hope my screen is visible. So coming to the question 3, let's study the question first. So what the question says is that chef has a unique way of cutting ground pizzas. He starts by cutting the pizza in half and then into quarters, then 8 and so on, always cutting through the center. Now, if we see the diagram here, what the chef is doing is that he is cutting the cake in the diametrical fashion. Okay, so first what it's doing is that it's cutting the cake into half and then it's cutting it into quarters. Now, it's not directly cutting the cake into the 8 one, but what it's doing is that first it will place the cutter here. So, what we can see is that there are 6 pieces that are split in the third step, and in the coming step, it is converted into 8 pieces, and so on. So, these are some of the cases. So, what the question wants from us is that chef wants to cut the pizza into X slices where X is always even. So as we are splitting the cake into halves at each step, so obviously the number of pieces that will be result due to this procedure will be even. So what our task is to determine the number of pieces that will be smaller than the rest. So what it means is that, like in step 3, when while doing the quarter pieces of the cake, what we can see is that 4 of the pieces having the small size, right? But coming to the next step, when we are placing the cutter like this fashion, the size of this piece and this piece are not equal. Like this one is unequal. So what we have to observe is that when is this phenomena is occurring? Okay. Now we can say that whenever the pieces are cut it into like the number 2, 4, 8, or 16, what we can observe is that the size of each pieces are equal. Okay, so so when the occurrence of this unequal sizes are happening, so the answer is that every time whenever the number of pieces are equal to 2 to the power k, where k is a whole number, this phenomena occurs. Okay, so by observation, what we can say is that, let's say there were 4 pieces, and in the next pieces, when we cut it the cake in this way, it converted into 6 pieces. So what happened is that we can see is that if we just see the fashion here, by one cut, how many asymmetrical pieces are forming? 4, because if we cut it diametrically, then there are 2 pieces which are touching the diametrical line. Now if we cut these 2 pieces, then 4 pieces will form. Okay, so similarly, if we see the fifth one, that after the 8 portion, whenever the 7 portion is hitting here, like whenever the cake is cutting like this, it is also forming four new pieces. So by observation, what we can see is that let's say there are asymmetrical pieces. Okay, there is a presence of asymmetrical pieces. So before when the asymmetrical pieces started to occur, before, let's say there were 2 to the power k pieces, right? Because what we observe that this phenomena only occurs once the pieces are equal to the 2 to the power k, where k is some whole number. So once we got this one, we will count throughout the way how many pieces were formed. So how, in what way we can do is that the number of pieces that is formed, that is in input we provided as x, and then we will minus the the nearest number which is in the form of 2 to the power k, but is less than or equal to this number. Okay. So once we get that number, we will ultimately multiply it by 2, because since there are two pieces and cutting it with one diametrical line, it will produce the double of it. So the process is understandable. Okay. All right. So yeah. Now coming to the procedure, here we can see the process. The process that have been explained. It's clear to you, right? Okay. So let's see the code running here. So here what we can see is that these are the test cases that we are taking, and under it we will be taking X here. So X is the number of pieces that the chef has assigned. Now the thing is that we need to check like which power of 2 is the nearest to that number and also less than or equal to it. So for that, we will initialize one variable ini, and then we will find that thing until it crosses the x level. Okay. Once I found that, if it's equal to x, then obviously there are no asymmetrical pieces like we saw. If we cut in that fashion, and if it becomes equal to sum of the power of that two, then there will be no asymmetrical pieces. Then we will print 0 in output, or else what we will do is that we will just take the difference of these two variables and multiply it by 2 and provide it as an output. Okay, so let's take the test case here. So since you can see that the constraints are also 10 to the power 5, then we don't have to really focus on optimizing the code here. So here it is. And like we can see 012 in this number, and the number is same here only. So I hope this process is clear to you. Now coming to the question number 2, did you guys solve this question? You can share your approach for it. Please, which two expressions may I know? Okay. The first one you did is the same only, just you have used a pointer variable inside it. So by all over, it's providing the same thing only. Okay. Here, what you have took excess. Okay. Okay, while you're sharing the code, I'll be explaining the next question. Okay, so let's focus on that. You share the code in the chat box. All right. Okay, first let's focus on the next question for now. Okay, have you done this question, the array removal? You can share your approach here. All right, so let's understand what the question is saying here. So you are given an array of size n. An integral array is given of size n. Your task is to determine the minimum number of elements that need to be removed from A such that the bitwise or or the of the remaining element is 2 to the power x minus 1 for some integer x, where x is greater equal 0. Note that the bitwise or of an empty array is considered to be 0. Now, the thing is that what they want us to do is that, let's say we have an array, okay, and it have n inputs. Now, what they want is that we need to remove minimum number of elements from the array, so that when we take the bitwise OR of each element in the array, the output in the, let's say in binary, will be some sort of like 1111. Okay, the number will contain only one. There will be no zero. Zero might present like after all the one appears, but like what it means is that if we say 2 to the power x minus 1, we can say it is the GP sum, right? We can write it as 1 plus 2 square plus dot 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 2 to the power x minus 1. So if we convert that into a binary number, what we will get is that a binary number having only one, no zero in it, right? So what we want is that from that array we need to remove minimum number of elements, such that when we take the bitwise OR of each element, the rest of the elements, the result will be provided as a binary number containing only one. Okay, so how we will do that? There is a simple way of doing is that what we can do is, first we can just sort the element, right? If we just sort it, and what we will do is that if the number is smaller, okay, obviously if all of the elements are one, then there must be odd number containing in it, right? If the condition is satisfied. So if we sort the number, the smallest element that will appear in the first, it will automatically satisfies the condition once all of the one appears, right? Which number will cause the problem actually? The numbers that are bigger, like let's say a number appears like this, say 1 0 1 1 1 1 0 1. Let's say this is the output of the bitwise OR of each element of the array. Okay, so while taking the smallest element, it was going fine only. Okay, now on the way a number appeared and it disturbed the pattern, something like this. Okay, and if we go furthermore, then we can see there's another number which disturbed the pattern. So when this disturbance is occurring, once we hit the large number with respect to the frontal number, right? So we need to see in which case or in by which number the disturbance is occurring. Okay, but if we say, let's say we hit another number in which the let's say we hit another element in which the number occurred something like this, like the place which contains 0, the biggest number contains one inside it, right? And the rest of the part are 0. Okay, now if we take the bitwise or of this number, what we will get? We will get a number that will having all of the number as 1, right? All of the number as 1. So we need to take care of this also. Like we will track the count of the number that is creating this sort of disturbance. But once the disturbance is restored, we will just reverse the count back to 0, because we need to keep the number of removal minimum. Okay, so if there's no need to remove any sort of number, then why would we do that? I hope this logic is clear. If so, then you can write it on chat. Okay, now coming to the code, let's see. So this is the code. What we will do is that, as usual, we will take the test cases, and then we will take the size of the array, and we will introduce one array with having data type long. Okay, because as it said that we will be having numbers that will be less than 10 to the power 9. Okay, you will see in the constraint. So in the first case, we will first sort it out. All right. Then we will introduce one variable count which will keep the track of the number which will be causing the disturbance in the array. Okay, and then we will have the previous number. Now this previous number is what we can say is that, let's say the sorted array was there, and from I equal to 0 to I equal to k. Okay, if we take the bitwise or of the this sub array, that value will be contained in the priv variable. All right, so at each step, while traversing through the array, what we will do is that we will give the priv variable. We will update the priv variable accordingly by taking the bitwise OR of the next element, and then we will just check whether this satisfies that all of the elements of the number is 1 or not. So I hope you understand this condition, that num and of num plus 1 is not equal to 0. You guys understand this? That if every bit of the number is 1, then if we add that number by 1 and we will take the AND of those two numbers, we will be giving 0 as an output. Okay, so yeah, so coming back to the code, so if it's 0, we will increase the count. Okay, but let's say that we hit another number and it kind of neutralized the effect of all the disturbance. Okay, so if the number is satisfying the condition, then just reset the value of count as 0. All right, so since we don't have to remove any number, we just make the count 0 only, or else we will increment the count by 1. Okay, so after this process, we will just print the count variable here. So let's test it under the test cases. So these are the test cases, and so the output are 2 and 2, and so that is given in the output section. So I hope it's clear, the logic is clear. Okay, now have you done the next question yet? Question number 5, did you try it? Okay, what was your approach for number 5? Okay, you share your approach. Meanwhile, we will study the question. So in number hunt, what they asked is that given a positive number x, find the smallest positive number y satisfying all the following conditions. Now, what are the conditions is that y should not be prime. The first thing is that, and y should not be a perfect square of any number, and no factor of y other than 1 is less than x. So now the thing is that what they have said is that there is a number x, okay, and we need to find the smallest y such that the factor of that number does not come between 1 and x, and also the number should not be a perfect square and a prime. So in this case, what we can do is that since the number is not prime, so we will eliminate all the prime option, and also it's not a perfect square. So what we can say is that it's a composite number. Okay, so if we take and if it's a composite number, then it must have also factor, right? So we need to make sure that the factor of that number does not does not become less than x. Okay, if it's equal to x, then it's quite normal. Okay, so one of the option what we can do is that since the factor of that number is not less than x, what we can do is take two primes that are greater equal to x and which is closest to x, because we need to find smallest integer. What we can do is that in order to take the smallest integer, we will take the nearest 2 prime to the x. Okay, now there is a thing that x can also be a prime number, so we can take x also and we will take another prime which is not equal to x. So what our motive is to select two distinct primes that are greater equal to x and also closest to x. Okay, so you understood the approach here? Yeah. So this is the approach that we will do. So what we can do here is that there are some procedures. So you need to select the prime numbers, right? So how would you do that? Now there are some theorems that you need to understand here is that like the factor of any let's say the prime. All right. Let's say there is a prime and uh, uh, if it's a prime, then the prime is always in the form of 6 mod plus minus 1. Okay, like if we take the remainder of a prime dividing by 6, then the value will the remainder will always be either 1 or minus 1. Okay, and what we can say is that we can test the prime by running a loop from like from 1 to root n. Now it's a theorem that the factor of that number, like if let's say there is an integer n, and if the number between the 1 and root n, if no number can divide that number, then it's a prime number. It's a possibility. Okay, and in order to recheck that whether it's a prime or not, we can check it by the 6 mod definition by taking the remainder from here. So what we can do is that we can just run a loop here that if n is less than or equal to 1, then we will ultimately return false because there is no prime there. And if it's less equal to 3, then we have the option to n3. So we will return true. And if it's divisible by 2 or 3, then we will return false because it will become a composite number. It won't be a prime. And then we will run the theorem part. That is that we will run from the loop 5 to root n. That is I star into I star. I square is less equal to n. Okay, so the complexity of this loop will become root n. Okay, on the way, if it satisfies this condition, that modulus 1, then it will ultimately return the false, because if it is not in the form of 6 mod plus minus 1, then we won't be considering it as a prime. That is to recheck the fact. Okay, and if all of this condition are satisfied, then we will return true ultimately. So this is the theorem that you need to understand. So I hope it's clear. If it's clear, then you can write yes. Okay. Now this was the function for checking whether a number is prime or not. Now the second thing is that you need to track down two primes that are greater equal to x but closest to x. So what we can do is that we can form one unordered set here that is called prime, and while we will run a loop while, and we will check whether the first number is prime or not, and if it is prime, then we can just append this element in this prime set, and if the size of that set becomes greater equal to 2 or basically equal to 2, then we will break the loop and we will return the multiplication of these two elements. All right, so this is a simple process only, just you need to know how to check whether a number is prime or not. So let's test this code. These are the input tests. And okay. So what we can see is that the output is 6, 6, and 15, and so is here. Okay, so this step is clear. Okay, so any doubts in these three questions, in the procedure or implementation of these questions? Okay, yeah, your code was there, right? The result is equal to See what this ultimately what this actually becomes if you expand this expand this expression, it will become 2 into x minus value, right? Yeah. So the expression ultimately will be equal only. So if the x is equal to value, then you will simply just return the 0, or else you will just return this expression only. Got this? Yeah. So any other doubts? Okay, so we will be closing the session here.